Let S be the set of positive integers n with the property that the last 4 digits of n are 2020, and when the last 4 digits are removed, the result is a divisor of n. For example, 42,020 is in S because 4 is a divisor of 42,020. Find the sum of all the digits of all the numbers in S. Interesting. So the first thing I'm going to do is I'm going to represent the numbers in S in a different way. So we know that n is going to be equal to any number that's in this set S is going to be of the form 2020 plus 10,000 K. So K, it kind of represents all of the digits in the number n other than the 2020. So for example, 42020, this is equal to 4 times 10,000 plus 2020. So in this case, K is equal to 4. So what I want then is when I remove the 2020 from the number, the result divides the entire number. So K would have to be a divisor of the whole thing. Ooh, that makes things a little weird. So K divides 10,000 K plus 2020. Well, am I then just not looking for divisors of 2020? K, of course, always divides that. And so I just need divisors of 2020. Let me try and think of let's first find an example of another number in this set. Let's let K. Let me see if my intuition is correct and just choose an arbitrary factor of that. 20 is a factor of that. 20 divides. In fact, let's use something a little bit less. Let's stop repeating these digits 2 and 0. 101 divides that. 101 divides 2020. So then I have the number 101 2020, right? This corresponds to K. K is equal to 101. So I have 101 multiplied by 10,000, and then I put a 2020 after that. And the number 101 also certainly divides that, right? If I take this and divide by 101, I get 10,000 plus 20. Yeah, so I'm just looking for factors then, all the factors of 2020. This shouldn't be too hard actually. Maybe we first write the prime factorization of 2020. Well, it's 101 times 20. which is 101 is prime, right? I think. Sounds prime. Okay, so yeah, I'll write this as 101 times 5 times 2 squared. And I'm going to put a 1 in there just to make sure we do have to count that 1. So what are all the factors? We have 101, 505, 202, 404, 2020 itself. I think those will be all of the factors. Oh, and 1010. These are all the factors that include a multiple of 101. Now let's do all the ones that don't. 1, 5, 2, 4, 20, and 10. Yeah, I think that should be all the factors of 2020. And I want the sum of all the digits of the numbers in S. Okay. So the sum of the digits, so these are the factors of 2020. So the actual numbers in S, I can write out the entire set S then. Right. All I'm doing here to get all the numbers in S is just writing out all of these numbers followed by 2020. I can do the same thing for that. I'm not going to write it all out because we're asked for the sum of all the digits. So first we realize that 2020 itself will appear 12 times in total in this set, right? There are 12 factors here. So the 2020, the tailing 2020 appears 12 times. So we have the sum is going to be 12 times 4. 4 comes from the sum of these digits, plus I just have to now add up every digit here. So it'll actually just be 1 plus 5 plus 2 plus 4 plus 2 plus 1. Let's see, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then I'll have to multiply that by 3. So I have 48 plus 45, which is 93. And that's my final answer. Pretty confident about that. The reason I took the 15 and multiplied by 3 is because these digits, these non-zero digits, all appear 3 times, right? There's another copy of that set and another copy of that set, and we just wanted to add the digits up. Yeah, so nice little problem. I was a little bit, I guess I could say, more intimidated at first when I looked at this. I thought classifying all the numbers in the set S would be a bit more difficult, but once you write this down, you realize all the numbers have to look like that. and then you're looking for numbers k such that k divides this whole thing, well, k always automatically divides that part. So we're just looking for factors then of 2020. And there aren't that many. If you identify 101 as a factor very quickly, then it's pretty clear there won't be that many factors in total. Yeah. So my answer here is 93. If I find a mistake, I'll write it down in the description. Thanks for watching.